So symmetry, so here's some rules about symmetry. So symmetry with respect to the polar axis. And the polar axis is the same as the x-axis. So if I have some line, let's see what this is going to draw here. So here's my polar axis, and here's the y, or this is called the pi over 2 axis. So if you have something that has symmetry with respect to the polar axis, like I'm going to try to draw a shape, but I don't know how well I'll do. But maybe I do have a cartoid shape, like something that looks, right? Oh, that's not right. Say I have this, I don't know. This is just some shape that's not very good. Let's go back. Let's try to make a cardioid shape. So if I have something that does like this, kind of a heart shape, okay? And then goes out here like that. That's not very good either. But this figure has, that has symmetry kind of with respect to the polar axis. The way you check for symmetry is if theta can be replaced with negative theta, and the equation does not change, then sim with polar axis. So for example, say I have something like 2 plus 2 cosine theta, r equals, and I were to take theta and plug it in here. So I'm going to take r equals 2 plus 2 cosine, and I'm going to take negative theta and plug it in here, negative theta. What happens when I take the cosine of a negative angle? Hello?
Opposite.
No, it's the same, right? Cosine is an even function, so the cosine of a negative angle is the same as the cosine of a positive angle. So this is equal to 2 plus 2 cosine theta. So since when I plug in negative theta in here and I get out this, then that has symmetry with respect to the polar axis. So what's nice about that is if I'm graphing this by hand, I only have to graph half of it, right? And then I can just sketch into the other half without ever having to do this. For the most part, things that are cosines functions, if it's just got a cosine function, it's going to have symmetry with respect to the polar axis. If it's just a sine function, it's going to have symmetry with respect to the y-axis. If it's r equals or something like that. So let's talk about symmetry with respect to the, let's see, can I just go back a whole bunch of times? Oh, that's wrong. What if can I erase all this stuff? Just erase. Symmetry with respect to the, I'm going to erase all this. I'm going to erase this. Will this work? Never. And start with a new page. So, new page. So if I wanted to check.
Are we supposed to drawing these on the back or what?
What?
Are we supposed to drawing these on the back?
Not yet, no. So we're going to graph one by it. So symmetry, if I want symmetry, Daniel, write down. Symmetry with respect to pi over 2 axis, that's also known AKA as the what axis? Where's pi over 2?
Y-axis.
Yeah, that's the same as the y-axis. Good. If theta can be replaced with, is it theta minus pi or pi minus theta? With pi minus theta, and the function doesn't change, and sim with respect to pi over 2 axis. So, for example, something that might have symmetry with respect to this might be a limaçon with a loop. So something that might look, is that what it looks like? No. It goes inside of the circle. So if I went, would it look like that? Right?
If you made that total. Yeah.
Well, anyway, that's something that has something with symmetry with respect to the pi over 2 axis. So for example, say I have something like 3 plus 2 sine theta. Now I told you already that if it's just plain old sine, it's going to have symmetry. If it doesn't have a cosine in here as well, and if it doesn't have an r squared, if it's just something like this. But to show you that this is true, I'm going to plug in 3 plus 2 sine of, and now in here I'm going to put in pi minus theta. And to show you that this is the same, 3 plus 2. Now, this is like the angle subtraction formula. That remember that? Alpha minus beta. Anyone remember what that was? It's like this. Sine A cosine B minus cosine A sine B. Okay? And if I simplify this, I get 3 plus 2. Sine of pi is what? What's sine of pi?
0.
0, right? So this term goes away. This is like 2 sine 0 cosine, not sine pi, sine 0, right? So this is like 2 sine 0 cosine pi minus, what's a cosine pi?
Yeah.
The cosine of pi is 0.
-1.
Negative 1.
Oh.
Negative 1 sine, whoops, that shouldn't be d, that should be a theta, right? That should be a theta, okay? Sine theta. And so I get negative 1 sine theta. And what happens is, since this is 0 times something, that goes away. And this becomes 3 plus 2 times times a negative makes positive 2 sine theta, which is what I started with. You understand? So this and this is the same, which means I only would have to graph half of this function, and then I could sketch in the other.
So that goes for all functions with just a sign in them?
With just a sign, except if it's squared.
So do you
which
want
is-
us to show that at work on homework and tests?
Yeah, if I want you to show that this function has symmetry with respect to the pi over 2, that's what I want you to do. Okay? All right. God bless you. Next thing about symmetry, and then we're just going to graph a function, and then we'll be done. So symmetry. That's okay. So symmetry with respect to origin, okay? And that's kind of like if you have something that looks like, if you have little loops like that, the one on the back of the sheet there, if you have something that looks like this, like a pedal design, okay? Kind of like that, like a that has symmetry with respect to the origin. Okay? Because if I flip this 180 degrees, it would basically look the same. So if, with respect to the origin, if R can be replaced with negative R, then sim with respect to origin. And the only place you're going to see those is if you have squared. So if you have like R squared equals 2 sine theta or something like that, then that one's going to have symmetry with respect to the origin, because if I take negative R and plug it in here, right? Negative R, square it equals 2 sine theta. I get R squared equals 2 sine theta, which is what I started with. So in that case, you only have to sketch here and possibly here if you have something over here, and then rotate it 180 degrees and you get the half of it.
Why the
Okay.
2 sine theta? It says here that it's sine 2.
Oh, I just made one up. I did. Right. Nothing. Okay, so now we're going to try to graph one of these things by hand. So we're going to try to graph that first one on the back side. I'm not going to go through all of these, so let's just look at
Do the rows with 4 petals.
the row. No, that's too hard.
Do it.
Rows with 4 petals by hand. No, let's not do that.
Yeah, let's do it.
We're going to do that in the computer lab. It would take too long because you have to find all the points in between. So by then,
It's scary.
I am scared. So let's do the cardioid. So I'm going to get, when I get back to that graphic or that paper that we're looking at. Oh, your note sheets. Let me go to my computer. Find it.
Yep.
Oh, I don't think I have to do that. I could just go here. Chapter 8. So, say this is what we did the other day, but say I wanted to do this one, and I want you to graph it. You may know what it looks like, but there's equations on the back, but I will make you do one at least by hand. So, so this is going to be a cardioid because these two things are the same, even though there's not a 1 cardioid, even though there's no 1 in front, right? It's understood that there's a 1. So the way I graph that is by taking a picture of it, and then I'm going to make a little table of values. How do I make a little table? Is there a fast way? You guys know. Let's try to make a table. Here's a table. That's a bad table. I don't want lines on me.
You just start up Excel, take a screenshot.
Oh yeah, I could do that. That'd be a good thing to do.
But then we
Let's
can't use
just-
your motion board.
I could start up Excel in this thing. It would work. So here's what you do when you're graphing by hand. You call this R and you call this theta. Alright? And this is going to come out looking kind of squished because this one doesn't go out very far. But I start by plugging in values for theta. Okay. So I'm going to plug in, let's move this. I'm going to plug in 0 for theta. So what sign is 0?
Sine of 0 is
0. So I get 1 minus 0. What's 1 minus 0?
1.
1. So the way you plot these, you're going to be plotting this point. So I'm going to go out 1 and around 0. So that point would be right about there. Understand? Then I'm going to plug in another number, probably on this at pi over 6. Okay, so this is pi over 6. So I'm going to say that theta is equal to pi over 6.
No wonder that they're pi over 6, is that pi over 12?
This one's, yeah, that's pi over 12, pi over 6, pi over 4. Okay? And so when I plug in pi over 6, anyone remember what sine of pi over 6 is?
1/2.
1/2. So I get out 1 minus 1/2. What's 1 minus 1/2? 1/2. So this is where it gets real squished because it says you go around pi over 6 and out 1/2 or over 1/2 and around pi over 6. So there's a point kind of like right in there. You see that? Okay, it's out 1/2 around pi over 6. Then I'm going to pick pi over 4. Anyone remember what the sine of pi over 4 is? Root of 2 over 2, which is about 0.7. Okay, so if I take 1 minus 0.7, I get out approximately 0.3. So this one's even inside of there and somewhere over here. It's really hard to, you know what? Yeah, I can't even see it.
Can't you just go like straight to pi instead of doing pi root 4?
No, because there's ones inside. So let's
too
kind
complicated,
of.
it's too small.
Yeah, it's too small.
Can we just
So let's say that, let's call this like 1, okay? And this 1 over here, this would be better. And so first point is going to be 0, 1. The next point is going to be like out 1/2 and around pi over 6. So maybe something like that, okay? The next point is going to be out 0.3, so about there, and pi over 4 around, so about 45 degrees, right? And then let's jump now to pi over 2, okay? What's the sine of pi over 2? 0. No, it's not. Sine of pi over 2 is, wait, you're right. Sine of pi over 2, no, sine of pi over 2 is 1. So I get 1 minus 1, which gives me 0, right? And so what I get is go out 0 and around pi over 2. Well, that's like, you're not really doing it. Okay, so now what I have is part of my cardioid. Okay? Now, because this has symmetry, I can kind of just sketch that it will go this way as well, right? To -1. And then, but I need some points down here. So how do I get some points down here? What do I need to plug in? Yeah, like negative numbers, like negative pi over 6. So negative pi over 6 is going to give me, sine of negative pi over 6 is negative 1/2. So I get 1 minus negative 1/2, which gives you positive 1.5. So what that says, I'm going to go out 1.5, and then I'm going to rotate through pi over 6. So maybe about there. Okay? And what? I should have got like a bigger piece of graph paper. So very good. Then pi over 4, negative pi over 4, is going to give you 1 minus 0.7. So that's going to be like 1.7. So it's going to be like a point out here somewhere. And then finally, let's jump to negative pi over 2. What's the sine of negative pi over 2? Sine of negative pi, what's sine right here? -1. So you get 1 minus -1, which makes 2. So that means go out 2 and rotate through pi over 2. So we should have done this on Valentine's Day, shouldn't we have? Okay? Which is in a couple weeks. Because look at the pretty shade. Oh. Okay? Then you have to do this.